This is lesson 6 of the Forces in Motion topic for GCSE entitled Doing Work. By the end of the lesson you should be able to tell me that work done is the same as transferring energy. You should be able to calculate work done, and if you're doing the higher paper you should be able to calculate work done when the force applied is not directed along the same direction as the motion of the object. Okay, for your notes, titled Doing Work or Transferring Energy. In physics, doing work or transferring energy means moving a force through a distance. It can be calculated using the formula below. This is one of those that you have to remember, so please highlight it appropriately in your notes. I've given you a little triangle here to help you swap it around. You're going to get some practice at doing that in a moment, and here are the definitions of the symbols with their units. Okay, let's give you a couple of examples of a calculation then. Firstly, it says calculate the work done when a 5 kilogram mass is A lifted through a height of 2.5 meters. Okay, well that's straightforward enough. Work done equals force times distance. The force, well, we're working against the force of gravity, so we're working against the weight of the object, and the weight, if you remember from previous lesson, is equal to mass times gravitational field strength mg times the distance. So our mass is 5, gravitational field strength 9.8 newtons per kilogram, and the distance 2.5, which gives us 122.5 joules. Now part B, this time we're dragging it across the floor, so we're not working against gravity, we're working against friction, so we don't calculate the weight. So this time the work done, force times distance, is the frictional force that we're having to overcome times the distance. Frictional force, we're told in the question, is 3, 2.5 is the distance that we've moved it, and we get an answer of 7.5 joules. Now if you compare those two there, and I think you probably agree that it usually requires more work to lift something than to drag something, because we're working against the force of friction and not against the force of gravity. Pause the video now and make sure you've got all that in your notes. Okay, have some practice in that then. I'll put the triangle at the top here to help you remember how to swap these equations around. There are 6 of them. Jot down the answers in your book. Use the shorthand notation W equals Fs if you choose. Okay, again, pause the video, have a go at those 6 questions. Question 1 is straightforward. We're asked to work out how much work done. Well, if you remember, work done equals force times distance. 650 times 4 gives us 2,600 joules. Question 2, again, it's a work done problem, so work done equals force times distance. 140 times 5 gives 700 joules. Question 3, you're asked to work out the force, so we use our triangle, cover up the F, and we're left with W over S, work done divided by distance. So we have 432 divided by 24, which gives us 80 newtons. Question 4, we're asked to work out how far. So we're after a distance here, cover up the S. Distance S is work done divided by force. 1500 over 250 gives 6 meters. Question 5, work done equals force times distance. 500 times 1300 gives you 650,000 joules. And lastly, you're asked to work out the force again, cover up the F. Work done divided by distance, 6,000 divided by 100, which gives you 60 newtons. Okay, just to follow up from that then, set you a short Seneca task, only take you about 10 minutes, entitled Mechanical Work Done. When you've completed that, if you're doing foundation, that is the end of the lesson. You need go no further. So you can stop the video now. If you're higher, complete this Seneca exercise and come back. Okay, so for higher students only, what if the direction of force is different to the direction of the motion of the object? Well, let's give you an example of that then. So imagine we're trying to pull this mass here with a piece of string, but instead of pulling it sort of horizontally like that, we're actually pulling it at an angle. The distance we've been given is a horizontal distance, however. So we can't simply use work done equals force times distance because the force isn't in the same direction in which we're moving it. So what do? Well, what we do is we work out the component of that force in the direction in which we're moving it. Okay, so the component of the force, hopefully you can see that that's F there, horizontal force, and it's adjacent to the angle, not opposite. So we're going to use that force F is equal to 10 cos 30. So 10 cos 30 gives us the size of that component, which gives us 8.67 newtons, and then our problem is nice and simple again. Work done equals force times distance, 8.67 times 5, which gives us 43.4 joules. Okay, to reinforce that then, just have a go at the following few questions. I'll give you a commentary through the answers when you've attempted those. So, question 1, question 2, question 3, have a go at those now, please. Okay, question 1. It's important to realise that they're both actually doing the same amount of work in theory. They're both taking that mass and they're lifting it through a height of 2 meters, so they should do the same amount of work. So if that's true, then pick the person whose work done it's easier to measure, as it were, and clearly that's got to be the man, isn't it? Because if work done equals force times distance, he's working against the weight of the block, and the weight is simply m times g, and the distance is moved is s. So it's 30 times 9.8, which gives us 588 newtons. We could use the same equation here for the girl, but we'd have to work out the component of the weight down the slope, and that's an extra step that we don't need to do really. Question 2, explain why the woman needs to use less force to lift her rock. Well, although she's doing the same amount of work as the man, because she's moving that rock through a larger distance, then it means that she's going to require less force. So if work done equals force times distance, if the distance is larger, the force needs to be less. And finally, in practice, the woman will need to do a little more work than the man. Explain why. Well, simply, this is not a frictionless slope. She has to overcome the force of friction as well as the force of gravity to do that, and that would add to the amount of work that she has to do. But that's often ignored in questions. Okay then, so from today's lesson you should know that work done means transferring energy. You should be able to calculate work done using the formula work done equals force times distance moved in the direction of the force. And if you're a higher student, you should understand that for forces that do not act along the same direction as motion, you must use the component of the force in that direction. And that's the end of today's lesson.